Okay, so number 7. In an electricity experiment, a 1.0 gram plastic ball is suspended on a 60 centimeter long string and given an electric charge. A charged rod brought near the ball exerts a horizontal electrical force, F vector elect, on it, causing the ball to swing out to a 20-degree angle and remain there. A, what is the magnitude of the force of electricity? And B, what is the tension in the string? Excuse me. So this question is going to be a teensy bit easier than some others, but it is a little bit tricky at the same time. So what is the magnitude of FE here? And make sure that your calculator is in degree mode for this problem because we have a degree sign here, so we know that our calculator needs to be in the same mode as the units given. So we know that the magnitude is essentially the length of a vector. And so we really need to find the length of this vector here. And so what this situation looks like is we have a ball that was sitting here, but the electric charge applied this way, made it swing out at 20 degrees and stay there. So our free body diagram looks a bit like this. We have the electrical force going this way, we have gravity as we always do going this way, and then we also have tension in the string going that way. And then we have our 20-degree angle right here. Now we know the force of gravity. We can find the force of gravity by multiplying the mass of the object by the acceleration due to gravity. So we're just going to get 0.0098 kilograms meters per second squared. And this is going to be really important for a little bit later. Now this diagram doesn't really show us what kind of trigonometry we can find to find what these values are. So we're going to kind of change it up a little. So in the horizontal sense, we have this. So what I did was I just moved this over so we can use the tension, the relation between tension and the force of electricity. And we can see that we can form a 90-degree angle here, which is perfect. We love 90-degree angles. We love right triangles. And so because of this, we can find that the force of electricity is equal to tension T vector times sine of the 20-degree angle. And we're going to remember this for later. Now in the vertical sense, we're going to be relating the tension to the force of gravity. Now what I did was I just moved this down here. So it's like this, and it was just so we can find another 90-degree angle, which is perfect. So we found that the force of gravity is equal to the T vector times the cosine of that 20-degree angle, yet again, because it's right here. So if we divide these two here, we get T sine of 20 over T cosine of 20 is equal to F of E over F of G. And we find that the tangent of 20 degrees, because the T's cancel out, is equal to the force of electricity over the force of gravity. And now we can just solve for force of electricity. We can plug in the force of gravity that we found here, and we get the force of electricity being 3.57 times 10 to the negative 3 newtons. Sorry, I completely blanked on that one. And now we can find the vector of t. So we can literally just plug this in to what we found earlier, or we can plug in f of g. It doesn't really matter, it's going to get the same answer. So we plugged in f of e into our equation earlier, and we rewrote it to find t. And we find that t is equal to 0.010 newtons. Now for this question, our learning goals were how to draw and interpret free body diagrams and identify and relate different forces within each other. This question was really, the tricky part in this question was just figuring out how to relate these things graphically so we can find right angles and use the trigonometry that we have been practicing this entire term and for the better part of our science and mathematic careers. And so, yeah, thank you very much. I hope you have a lovely day.